Good morning, guys. So far we have completed mini piano, potentiometer, and fading LED. So I was told that you guys are doing really well, and you have completed fading LED so soon. That is great. If you just have enough time, I want you guys to review the projects that we have done, because every day we are doing a new project, but at the same time I don't want you to forget our old projects. Okay, so please review the old projects if you have enough time. In today's class we are going to start and learn about photoresistor. So let me create a new document, because photoresistor is actually a sensor. Okay, so name this as 2.4 photoresistor underscore your name underscore your grade. Okay, again, to start the topic I'm going to write it as a heading and Times New Roman 2.4 photoresistor. Okay, so there's nothing much. I just want you guys to know about it, what exactly is photoresistor, and font size should be 12. A photoresistor a photoresistor is also known as a light dependent resistor. Photo, here the name photo, the term photo means nothing but photon, which is present in light. Okay, not proton. Protons are something that is in the atoms. This is photon. Okay, photon is a packet that is present in light. Okay, a photoresistor is also known as light dependent resistor. So what does this mean? It's actually a resistor. It has the values of resistance like a normal resistor, but it acts differently in the presence of light. Okay, it is a semiconductor. It is a semiconductor which has variable resistance depending on the intensity of light. The intensity of light is also called as lumens. The intensity of light is also known as lumens. Okay, now how does it look like? You guys know how to insert an image, right? So just go to insert image, search the web, photoresistor. Okay, this is exactly how it looks like. We do have some of them in our kit. Okay, let me take this image. And you know the rules of an image. So go here, instead fixed position on page, so put it on this side. Okay, and then once we are done with the code and the circuit, we'll just paste our two images over here. Okay, so now let us go to Tinkercad. Create a new circuit. I'm gonna name this as 2.4 photoresistor underscore your name underscore your grade. Okay, now first thing is you would definitely need an Arduino, and you would also need a breadboard. Okay, so let me keep it this way. Now, to make this work, first let us get the LED, and then let's say I'm gonna place it somewhere over here. And you know that LED has cathode and anode, so let's say the cathode, I need a resistor. I need a regular resistor which connects down to this one, and you can keep it at 1 kilo ohm or you can change it to 220 ohms. And on the other side, I'm gonna take a photoresistor. Okay, I'm gonna take a photoresistor. So you need to look for a photoresistor. Okay, it looks like this, and keep it over here. Okay, so this photoresistor, what it does is, like, there is a way to increase, once we start the simulation, there is a way to increase the light and decrease the light that is falling on this photoresistor surface. To do that, first I need to connect it to a regular normal resistor. Let me connect it over here. Perfect. And to make this work, it needs 5 volts. Okay, so that means I need to take a cable and connect it to the positive, but this positive sign is not receiving any 5 volts, so I need to add 5 volts to it. Okay, I'm gonna take 5 volts, and what else is I need to do? Ground. So I'm gonna change the color to black, take the ground cable, connect it over here. Okay, so my resistors are now connected. Now I need to take a point from 9 or any of these pins. I'm just considering 9 this time, and then connect it to over here. Perfect. Now, as I told you, this photoresistor can read the intensity of light, which is an analog input, right? So I'm going to take another cable. Whenever I'm taking another analog cable, I'll try to keep it as blue. From the same ports, from the same thing, from the same terminal. No, here we are giving 5 volts. Sorry, from the same terminal where the resistor is there, I'm going to pull out another cable. And then connect it to any analog pin. Let us say here, let me use the A0. You remember I told you here these are analog pins, these are digital pins, and because this is an analog input that we are reading, that is the strength of the light, the lumens of the light is something is falling on this surface area, and we are going to read this. So for that, I'm going to use an analog input A0. See this, I put it at A0. Please be mindful about the connections. 5 volts ground A0. On this side it is only 9. Okay, that's it. The circuit is very simple. At the same time is the code too. But this time you need to create a variable which is called as, like, you remember button value, something like that. We are going to create here sensor value. Sensor value. Okay. So you need to set the sensor value. Okay, let me do one thing. Let me move this a little bit. Increase the size, so you should be able to see it clearly. Set sensor value to, where is the sensor value going to? The sensor value is going to A0. So I'm going to go to read analog pin A0. Once this is done, if you want, you can do this. You go to output, print to serial monitor. I just want to print something. Okay. Print to serial monitor with new line. So instead of hello world, what I want to print is obviously sensor value. Okay. then output set pin 9. So this is our LED is connected to pin 9, right? So what I'm going to do is set pin 9 to, I'm going to create a function. Which says there is a range. Map, what should I map? Map the sensor value. I'm mapping the sensor value from the range 255 to 0. The reason why I told you about fading LEDs to understand and to use this 0 to 255. In fading LED you use the same numbers because the LED value has 0 means the darkest, 255 means the brightest, right? Perfect. Change this to 4. Yeah, I forgot to mention to try to change this to 4 kilo ohms and let us see how it works. And then go to control, wait for half a second, 0.5 seconds. Okay, so if everything is correct, it should ideally work. So the moment you click it and you click on this, the LED is on. Okay, let me show this. The LED is on when there is no light. So at this point there is no light that is falling on the resistor, but you increase the light, the LED is fading out. You see this? Okay, so let me do this again. When there is yep, so when there is full light, the LED is off. When the light is decreasing, the LED is on. What are the applications of this? I want you guys to think for a moment before you take the screenshots of this and put it in your document, because I want you guys to understand and write the applications as well. Take the screenshot of your work and post it over here, and you don't have to share it with me yet. I'll tell you when you need to share it with me. Some of you guys have started sharing with me in the documents. Please don't share it with me yet. I'll tell you how to do it. You need to turn it in the assignment once we create the assignment. Okay, now coming back to the topic, once your circuit is working and done, take a screenshot of your code and take a screenshot of your circuit and post both of them over here. And you also need to find out what are the applications, what are the real-time applications, where exactly is this used, these photoresistors are used. Try to find out at least 4 different applications and write down the applications as well. Okay, thank you guys. I'll see you in the next video. And next video is going to be our last video for the chapter 2, which is liquid crystal display or LCD. So stay tuned for the next video, but try to complete the assignment that I told you, including the applications of photoresistor. Alright, thank you guys. See you tomorrow.